Hello AP students. I'm going to talk a little bit about how to think about the neighborhood-based collaborative filtering algorithm. Here's the paper that we talked about in class, and it outlines the 3 basic steps to any neighborhood-based collaborative filter. So we're going to have an active user who we're trying to predict their rating of a movie. And the first step is to find a neighborhood for that user. And the neighborhood is all of the other users who are similar to the active user. And there are different ways to compute similarity, and we'll use the one that we talked about in class. Once you have a neighborhood of other users who are similar to your target user, you can see what they rated the target movie, and then you'd predict that the active user will rate the movie similarly. Alright, so some people asked kind of how do you think about this problem? What I want to emphasize is a really important skill that any good programmer needs, which is being able to break down a larger, more complex thing into smaller pieces to make it easier to think about. Here's the predict rating method. It takes a person and a movie as input, and it's supposed to return a double, which is our prediction for what will this person rate that movie. Alright, right now we're just predicting that the person will rate the movie 4. So let's think about what our first step was. Our first step is finding a neighborhood for the active user. So let's make that a sub-problem. I know a neighborhood is a collection of other users, so I can store that in an array list of person objects. And I'll call that neighborhood. And because I can't think about how to solve this problem right now, let's encapsulate it with a method. So, create neighborhood, and we'll give it a person as input. Let's assume this problem is solved. What do we do next? Next, we would want to use that neighborhood to make a prediction. So I'll make a double called prediction, and I'll create a new method called create prediction from neighborhood. What does this need in order to work? Well, it needs our neighborhood, and it also needs the movie that we're trying to predict. Why can't I type today? Alright, if we can solve these 2 pieces, that'll do it, and we can return the prediction. When I watch a lot of you program, you do not program this way. You try and start at the first line, and then you write the second line, and then you write the third line, which is sort of like how you might write, I guess, an essay. Although really, even when you're writing an essay, you want to write a structural plan first. I really want to emphasize that you need to be thinking from a higher level. You need to have a picture in your head about how all these pieces are going to fit together. So let's write the create neighborhood method. Alright, how am I going to create a neighborhood? Well, I guess I need to loop through all of the users and then have a way of figuring out when 2 users are similar. So let's do that. I'm going to loop through all the people. I can say tester.getAllPeople to get the people. One thing I want to make sure of is that I don't actually find myself as somebody who is similar to myself. So I'll put in a test for that. I'll say if p.getID equals person.getID if they don't equal each other. So only if the person I'm looking at does not equal myself. You know what? Already this name P and person are confusing. Let's rename them. So person is really active user. That's the one who we're interested in making a prediction of. Let's rename P to other user. Alright, already this is clearer to read. This is something else that I don't see a lot of people doing in class is as you're going, think about what really do these variables contain and renaming them something that makes sense. Alright, so I'm looping through all the other users. I'm testing to make sure the other user doesn't have the same ID as the active user, so is it really someone different? Let's find their similarity. So this is another tough problem, but it's one that's its own discrete operation, so I can make it its own method. And I know what it's going to return is some number representing the similarity. So I can say double similarity equals calculate similarity between my active user and the other user. Alright, cool. How does this work? I don't know. We'll think about it in a minute, but let's keep thinking about this method and make sure that, assuming that this is going to work, the rest of the method will work. Alright, so I'm looping through all the people, I'm calculating the similarity. So in our original algorithm here, it said that I want to select the k users that have the highest similarity with the active user. Well, I'm not setting myself up very well to find that, because what that sounds like is I would need to set a similarity rating and then sort the list of all of the users according to similarity. And I could do that. I could make a list and I could sort it. I think what I'm going to do instead is use a threshold value. So instead of choosing, say, the 10 most similar users, I'm going to have my neighborhood consist of all of the users that are sufficiently similar to my active user. And if that's 5 users, great. And if that's 50 users, that's even better. So let's decide the threshold. I'll say, if the similarity is smaller than, let's say, 1. And I'm thinking ahead here about what does similarity mean. The way we're going to calculate similarity is the average difference between the two users' ratings over all of the movies they've rated in common. So in that case, smaller is going to be more similar because it means that there were fewer differences. The differences were smaller in each case. So if the similarity is small enough, then, let's see, I need to add them to my neighborhood, right? Because I'm returning a list. So let's create the list up here. Alright, so now I've got a neighborhood, and I'll say neighborhood.add other user. Great. This is a bit of a magic number, so I probably shouldn't have that there. Let's replace it. Let's call this similarity threshold. And we can make it a parameter up here. Oops. Alright, so let's review again. I've got my neighborhood of people, I'm looping through all the other people, I'm making sure it's really a different person than my active user. I'm going to calculate the similarity. If the similarity is below the similarity threshold, then I'll add them to my neighborhood. Alright, and then I guess at the very end I'll just return my neighborhood. I've got to be careful because whenever I have a threshold, it might be the case that nobody is that similar, so when I return my neighborhood, I have to bear in mind that it might be size 0. So you can think about that. Alright, calculate similarity. Let's do that method. So here we are. We're calculating the similarity between active user and other user. So how are we going to do this? I guess first we have to figure out what are all the movies they've rated in common, and then look at the ratings for each one. So there's lots of different ways you can do this. I think we'll do it this way to begin with. I'm just doing a naive approach here. I'm not even thinking about making it efficient, which is probably what you should do the first time around. If we run it and it turns out to be super slow, then we can go back and figure out how to make this stuff more efficient. But I'm just trying to think what's the simplest way I could possibly do it. Okay, so simplest way, I think we should loop over all the movies that this person has looked at, and loop over all the movies that this person has looked at, and see if any of them are the same. That seems straightforward. So, I'm going to say movie M1 is active user.get. So I don't seem to have a method that gets what I want. What do people have inside them? Let's take a look. Well, I don't see a list of movies, but I do have a list of ratings. And I know that each rating object has both the person who rated it and the movie. So I know that this is really like a list of movies. So I want to make a getter method for these ratings. So let's make a getter method. Public array list rating get all ratings. Return ratings. Alright, we've done it. So back here in recommender, now I can get what I need. Get all ratings. All right, so this is looping over all of the active users' ratings. Now let's loop over all of the other users' ratings. Oops, I forgot. Okay, so this was lists of ratings, not lists of movies. So let's call this rating, and let's call this rating. So we'll call them R1 and R2. Okay, let's get out the movies. So movie M1 equals R1.getMovie, and movie M2 equals R1.R2.getMovie. So again, we're looping over every single rating of the active user, and for each one of those, we're going to compare it to every single other rating that the other user made. Again, this is going to be really slow, but that's okay. We can make it faster later. So now we know the two movies. What do we really want to know? We want to know if those movies are the same. So if m1.getID equals m2.getID, that must mean they're the same movie. All right. Why did we want to know if they rated the same movie? Because we wanted to see what was the difference between what they actually rated it. So let's add up here. We'll add an integer for movies in common. So that'll like count how many movies did they rate in common. And we'll have a double for difference sum. All right, so let's say movies in common. We'll increment that guy. Difference sum. Let's see, I want the absolute value of the distance because I just care about the magnitude of the distance, not what direction the distance was. So it must be r1.getRating and r2.getRating. So that's the difference between the ratings, and now I've added them up. And then down here at the bottom, if movies in common is greater than 0, so if there were any movies in common at all, then I can return difference sum divided by movies in common. All right, whenever I'm doing division, I double check. Is there integer division happening? No, okay, it's a double, no integer division. All right, well, wait a minute. What happens if they didn't see any movies in common? I still need to return something here. So I guess if they didn't see any movies in common, I want to count them as definitely nowhere close to similar. So I'm going to return something really huge so that way this other user is going to get filtered out as not being similar at all. So I'll return integer.maxValue. And since that's kind of a weird thing to return, let's add a comment. Return a very large difference to indicate no similarity. All right, so now I'll remember what that was about later. So where are we? Let's back up. Inside predict rating, now we have a way of creating a neighborhood. Why doesn't it like create neighborhood? Oh, right. I forgot we added this similarity threshold. So let's make our similarity threshold 1. So that means the average difference in the ratings has to be smaller than 1. All right, so we have the neighborhood. Now we're going to create a prediction from the neighborhood. That's the next step. So let's create that method. So when we create a prediction from the neighborhood, I'm not going to code this one, but maybe I'll kind of pseudocode it for you. What we really want to do is loop over all people in the neighborhood. Then we want to get their prediction, get their rating for the target movie. So it seems like we'll probably have to write a method, maybe inside person, where we give it a movie and it will look through all the ratings that the person has done, and it'll find that movie and return the rating. And we'll add that into an ongoing sum, and then at the end we will return the rating sum divided by the total number of things that we added. All right, the only thing that you have to be careful about in here is just because someone's in our neighborhood doesn't mean that they've seen the target movie. So you have to be careful in here. Maybe you have like an if statement that says if person dot has rated movie. So first you check if they've rated it, and then you get their rating. Anyway, you can work out those details, but that's how that's going to work. And then at the very end, we return the prediction, and that's it. All right, so let's take account of a couple of more things. I was just banging this out, with as little thought as possible, but now that it's all there in front of us, it might make sense to move a lot of this stuff around. So, for example, where we're looking at the similarity between two users. Where did I put that? Calculate similarity. It makes some sense to calculate similarity between two people, but it makes a little bit more sense to me maybe to make this a method inside person. So that way, if you have an active user, you can say active user dot calculate similarity to, and you give it an input of some other person. Or even calculate neighbor or create neighborhood. That could be a method inside person as well. Because both of these things kind of essentially have to do with people. And anything that is a property of a person, like a person's neighborhood, should be handled by the person class. So if I were going to do this over again, I would probably refactor a lot of this stuff to put things related to people into the person class. Let's do one last thing, speaking of in the person class. For debugging purposes, I think there's going to be something really helpful for us to add. So let's go inside person. I want to be able to look at two users and just see all the movies they've rated in common and what the ratings were. So let's write something like that. In this case, I think maybe I will make it a static method. So public static void display common movie ratings. And we got person P1 and person P2. Okay, so this is going to be sort of similar to our other code, so I'm going to drop the other code in there, where we were looping over both people. Here we are. So it's kind of similar to this code. So now active user is really person 1, and other user is really person 2, and we're getting all the ratings, and we're getting the movies, and if they've rated the same movie in common. I don't want to calculate things now, though. I just want to display things. So I'll say system.out.print, and let's print, because it's the same movie, it doesn't matter which one I choose, so I'll say m1.getName. I guess we can print line. That should be fine. And then I want to say person 1, and then let's display rating1.getRating. And then same thing for person 2. What this is going to let us do is it's going to give us a really nice way of visually checking just how similar are two users. Because the way we're calculating similarity is we're saying that their ratings for movies they've seen in common should be really close to each other. So this is a way of printing out the information that we think we're using so that we can double check it just visually ourselves. All right, I think this should be good now, and we can of course delete this down here. So now if we want to, back here in the recommender, when we're calculating, let's do it after the neighborhood, okay? So where here, I'm going to go ahead and comment this method out since we're not using it. So I just want to check my neighborhood and see how it looks. So what I'll do is I'll loop through my neighborhood, person P, neighborhood, and now I want to say person.display common movie ratings, because I know everybody in the neighborhood is supposed to be similar to my active user. So person is the name of my active user, and here I'll say P as someone who is allegedly similar, and now this is going to display, are they really similar or not? So let's run just this much and see what happens. I think I'm running the wrong thing. Hold on. Main. Alright, here we are. So I've stopped at midway. And indeed, look, I'm seeing person 1 and person 2 seem to be rating very, very closely. 4-3, 5-4, 1-3. That's a little bit far off. But in any case, this has provided a good kind of sanity check to make sure that this seems to be working. And if I'm unhappy with 5-3, look what we could do. How could we tighten up similarity? When I created the neighborhood, I said there had to be a threshold of 1. Let's make it be a threshold of 0.3 and see what it looks like then. Okay, so now we're getting people who are really very, very similar. I'm not seeing any of those really large gaps anymore. So there you go. I hope that's helped. Good luck, everybody.